Assalamu alaikum. I, Laiba Khurshid, along with my group member Hafiza Muniba Mohsin, will be presenting to you about series substitution method for solving the differential equations. Let's begin. What is series substitution method? Well, we know that we can effectively solve the linear differential equations, either they are homogeneous or non-homogeneous, having the constant coefficients easily. But what about the equations with the variable coefficients? We have special cases and we will discuss those cases in this presentation in detail, and we will see the general method for solving such equations. The basic idea is to assume the unknown function y that can be expanded into the power series. Y of x equals to a0 plus a1x plus a2x square plus so on. Like I said that we will see the general method for solving such differential equations. So that method is a power series method. A power series is a type of series with the terms involving variables. More specifically, I would say if the variable is x, then all the terms of the series involve powers of x. As a result, a power series can be thought of as an infinite polynomial. Power series are used to represent common functions and also to define the new functions. The power series method, it is the standard method for solving linear ordinary differential equations having the variable coefficients like we already mentioned. It gives the solution that will be in the form of a power series. Now, before going into the depth of power series method, let's see some of the application that power series have. The power series can be used for computing different values, for graphing the curves, for proving formulas and exploring the properties of given solutions. Now, mathematical functions can be classified into two different types. They are either ordinary functions with finite number of terms or they are power series with infinite number of terms. If we talk about the examples of ordinary functions, so they are of type such as y equals to x square plus 3x minus 1, y equals to x plus 1 over x minus 1, a is equals to sine of b. If we see such functions, then we will say that these are the ordinary functions having finite number of terms. Now, what about the functions having infinite number of terms? Well, the functions having infinite number of terms are called power series. Like we have example of y equals to summation k equals to 0 to infinity a k x minus x naught whole power k. If we open the summation, we get a naught plus a1 x minus x naught plus a2 x minus x naught whole square plus so on. So we see that this is the function with infinite number of terms. Likewise, we have infinite terms of the form summation k equals to 0 to infinity a k x whole power k equals to a naught plus a1 x plus a2 x power whole square plus so on. This type of functions are called power series in the x domain. Now we will see convergent and divergent power series. But before seeing that, let's look at some of the important points, like what are the ordinary points and what are the singular points. Whereas we have undefined function when a point x is equals to a is called a singular point of differential equation when p naught of x at x is equals to a is equals to 0. So we saw that for ordinary point p1 of x should not be equal to 0 at x is equals to a, whereas p naught of a should be equal to 0 when x is equals to a for singular points. Singular points are also known as undefined functions. Now, let's see the convergence and divergence of power series. We know that the terms in the power series involve a variable x, okay? Then the series may converge for certain values of x and may diverge for other values of x. For a power series that are centered at x is equals to a, the value of the series at x is equals to a will be given by c naught. Therefore, power series always converges at its center. Some power series converge only at that value of x, on the one value of x. Most power series, however, converge for more than one value of x. So there are power series that will converge on one value of x, or other series we will converge on more than one values of x. Most power series either converge for all real numbers of x or converge for all x in a finite interval. So we will see the examples how power series and now let's look at the example to clearly understand the convergent and divergent power series. Let's look at the first example where y is equals to summation n equal to 0 to infinity x raised to power n divided by n factorial. If we open the series in summation, we get 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial and so on up to the infinity. And this whole term equals to e raised to the power x. Similarly, we have y equals to summation n equals to 0 to infinity minus 1 power n x 2n plus 1 divided by 2n plus 1 factorial, which is equals to x minus x cube divided by 3 factorial plus x5 divided by 5 factorial plus x7 minus x7 divided by 7 factorial and plus x up to x infinity up to infinity factorial. So if we have the series of such a form, we will write the whole series equals to sine of x. And for the series to be equal to cos of x, the value should be 1 minus x square divided by 2 factorial plus x4 divided by 4 factorial minus x6 divided by 6 factorial. If we have series of such a form, that will be equal to cos of x. All of these three examples that I have mentioned are example of convergent series. Because x is equals to finite values, we have y which is equals to finite value as well. Let's look at the example of divergent series where when this happens when y equals to summation n is equals to 0 to infinity x raised to power n, which equals 1 plus x square plus x cube plus x4 plus so on. This is divergent at x is equals to finite values and y is equals to infinite values. So we can clearly distinguish between the convergent and divergent series by looking at the x and y values. For convergent, x has finite values, y also has finite values. Whereas for divergent series, only x has finite values, for y it has infinite values. Now, how we can solve the differential equation by using the power series substitution method? Well, if we have an equation of a form y double prime plus px of y prime plus qx of y equals to 0, we can easily obtain this solution by using the following steps. Number 1, we will assume that there is a solution of the given differential equation y, which is equals to summation k equals to 0 to infinity ak x minus x naught whole power k. It can also be ak x whole power k. Then number 2, we will find the first derivative of the solution, that will be equal to summation k equals to 0 to infinity ak x minus x naught whole power k minus 1. And we will then get another derivative of the solution, that will be equal to summation k equals to 0 to infinity k into k minus x minus x naught whole power k minus 2. Then what will we do? Number third step, we will substitute the values of y prime and y double prime in the given differential equation. Then we will equate to 0 the coefficients of various powers of x and find the constants a0, a1, a2 so on in terms of a0 and a1. Then number 5, we will substitute the values of constants in the given solution that we assumed, and that will be final required power series solution for our given differential equation. See, it is just done in 5 easy steps. We will see some examples and then we will also solve the examples by using the software MATLAB. Example, let's say that we are given the differential equation of a form y prime is equals to 2xy, and we are set to solve this equation by using the power series substitution method. We will first write the given equation in the form y prime minus 2xy equals to 0. Then we will follow the 5 easy steps that I mentioned earlier to solve this question. First step was to assume the solution of the given differential equation, that we assumed in the form of summation k equals to 0 to infinity ak x raised to the power k. Now let's take the derivative of the given solution. First derivative, we will get summation k equals to 0 to infinity ak x whole power k minus 1. Now see here, in the given question we just have to find first derivative, so we will just stick up to the first derivative of the solution. We will then substitute this values of first derivative and y in the given equation. We will get equation of a form summation k equals to 0 to infinity a k x whole power k minus 1 minus 2x summation k equals to 0 to infinity a k x power k equals to 0. Now what we will do, we have summation k equals to 0 to infinity a k x power k minus 1 minus summation k equals to 0 to infinity 2a k x power k plus 1. What we did, we had 2x in the second term, so we just added up the power of x. Now next step, we will substitute k to k minus 2 in order to make the coefficients same, so we can easily solve the question further. So what we will do then, we will equate the coefficients. First we will equate x, the coefficient of x 0. For the power for x power 0, we have only a1 equals to 0. Then we will see the coefficient k minus 1. For x power k minus 1, we have a k minus 2, a k minus 2 equals to 0. So for if we have k, the value of k greater than or equal to 2, we get a k equals to 2 by 4 a k minus 2. Now this relation that we got is known as the recurrence relation, and we will substitute the values of different values of k in this relation to get the variable constant, and our main aim and main goal is basically to get the values of these variable constants. So for k equals to 2, if we substitute k is equals to 2 in the recurrence relation, we will get a2 is equals to 2 divided by 2 a naught, and that is basically a naught. And like I said in while mentioning the rules, that we will have to get the answers of these variable coefficient in terms of a naught or a1. So we will see it here. For k equals to 3, we get a3 equals to 2 by 3 a1 equals to 0. For k equals to 4, a4 is equals to 2 by 4 a2, which equals to half a naught. Similarly, for k equals to 5, we get 0, and for k is equals to 6, we get 1 by 6 a naught. Like we said that we will, if we open the series there of the solution that we assumed, it will be equal to a naught plus a1x plus a2x square plus so on. So if we write the values of a1, a2, a3 so on in terms of a naught, we will get y of x equals to a naught plus a naught x square plus a naught x 4 by 2 factorial plus a naught x 6 by factorial plus so on. So y of x will be equal to a naught plus x square plus x power 4 by 2 factorial plus x power 6 by 2 factorial plus so on. And y of x then will be equal to a naught, that is a constant, e to the power x. Now if you look closely at the solution of this question, you will see that this solution is something that we already saw. Yes, you are right. When we were doing the convergent and divergent series, we talked about the values having x finite values and y finite values. If we have such a values of x and y, we called that solution convergent. So here we also have the values of finite values of x and finite values of y, so it is also a convergent solution of power series equals to e raised to the power x. Now we will plot this question on MATLAB as well. Now it's time for solving the differential equations using the power series method on MATLAB. Well, what is MATLAB? Well, MATLAB is a high performance language for technical computing. It is used to integrate computations, visualizations, and programming, etc. It is very easy to use, where problems and solutions are expressed in the familiar mathematical notations. We can do mathematical computation, algorithm development, modeling, simulation, and prototyping, etc. on MATLAB. We will solve the power series method on MATLAB. Now let's do some hands-on on MATLAB. If we have a function and we have to program the function and plot as well, the function can be any function, such as we have exponential minus x. We can perform the power series on the function and then plot it against the actual exponential. We will have to first clear the window by giving the command clear and enter. Then we will have to give the values for x1, which we have given equals to 0, 0.1 and 5, semicolon, and write the function, that is y is equals to exponential minus x1. Then figure, we will have to plot x1 with respect to y and k is for the color. The plot, we will have to plot the true function in the black. Okay, so k is for the black color. We will get the plot and the color of the graph will be black. Then giving the command of hold on to the MATLAB, because we will have to define further values. Ex of 1 equals to 0 size x1, and we will see that we will be using the commands such as for and AND while giving the power series function to the MATLAB. So for n equals to 0, 5 x1 is equals to x1 plus minus 1 dot power n multiplied by x1 dot power n divided by factorial n. So what we have done here, basically we have written the given exponential minus x in the open form, in the like we have opened the given question, and we will then give the AND command to the MATLAB, and then we will have to plot the function with comma r, and this r is telling us about the color of the graph. So there we can see the plot, as this graph clearly suggests that we were using the function of exponential form. Yes, we were, and we got the graph that is also showing the exponential function. Now let's do some more examples. We will be plotting a power series having the first non-zero term, sum of the first two terms up to the sum of the terms defined by the loop. The original function that is given is tan cos 50t. So how we will plot this function using the MATLAB? Firstly, we will give the number n equals to 400 and prompt where we will enter the numbers of the terms to sum up. I is equals to the input prompt, and firstly we will enter the numbers of the terms to sum like given in the question, sum of the first two terms. So t is equals to linspace 0, 300 and n plus 1. F is equals to, that is the function, that is equals to tan cos 50t. Then we will give j is equals to zeros 1, n plus 1 semicolon, and again the command of for and n. For n is equals to 1 colon 1. J is equals to g plus minus 1 power n steric 2500 power n steric t dot power 2 steric n by 2 steric factorial n. And we will get the command of AND, then again hold on, plot t comma g, and we will get a plot of t with respect to g. What this figure suggests, or this graph? Well, this wasn't a function in the exponential form, right? So the graph isn't in the form of exponential. It is a straight line graph that is showing that it is a linear function. The function was tan cos 50t, and we performed the power series substitution method on the function using this MATLAB, all these commands for the power series method, and we got a graph. We see the similarities in these commands. We have to use for and AND command for the MATLAB. For power series substitution method, we will have to use the hold on command. These are some commands that are important to keep in mind while solving the power series substitution method on MATLAB. The first two functions that we saw, we got a graph of these functions on the MATLAB. Now how we can get an answer of the given differential equation? Well, we can also get that using MATLAB. First of all, we have to clear all our workspace, clear all. CLC, we can also write CLC enter or clear enter. Now, as we have cleared everything that was stored before, then we will again have to define some symbols. The symbols that we will be using for this question are is only one symbol, that is x, so we will just have to write SYMS x. Then the function equals to exponential of x. Again, we have to scale the level for the function, for which n is equals to 4. Now, for 1 equals to 0 colon n, f1 is equals to differential, the command is diff, f comma x comma 1 semicolon, and for if we have to see the substitution for the given equation, we will have to give the command for substitution, and let's say we say f1 0 is equals to substitute subs f1 comma x comma 0, and what we have to substitute, we will also have to tell that to the computer. C1 plus 1 equals to 1 by gamma 1 plus 1 steric F10, and T is equals to 1 plus 1 equals to x power 1. And this is the command of and first we have given the command for 4. Now if we had to plot the function for this command, we will just had to write hold on and then the command for plot. But we are not doing plotting here. We are looking at the solution for the question. So we will have to give some further commands. We will write app func equals to C steric transpose T, and figure 1 explore f minus 1 comma 1, then hold on, then minus 1 comma 1 explode app func, figure 2 explode apps f minus ap underscore func minus 1 comma 1, where fun is a command that we have given for the function. And we will get the answer x power 4 by 24 plus x power 3 plus by 6 plus x power 2 by 2 plus x plus 1. So see, we just got the solution of the given command, that was f equals to exponential of x. Now we got the answer for the given question or the given equation, f is equals to exponential of x. And then we can further substitute different values of n. We will get different values of f1, 0 and t, and so on. And finally we will get two graphs of this given equation. First graph, it is of the function x is equals to x squared divided by 2 plus x cubed divided by 6 plus x4 divided by 24 plus 1. So this graph that is red line, this red line shows the given function. Then we will get another graph, and that this graph will be of the function x minus exponential x plus x squared by 2 plus x cubed by 6 plus x4 by 24 plus 1. This graph, it is with blue colored line. This graph shows the answer, and this graph shows the equation of the given function f equals to exponential of x. Now we can also fit a single term power series model to the MATLAB. We will have to give the command in the command window, general model for power 1, f of x equals to ax power b. Then the coefficients with the having the 95% confidence bounds, the values of the coefficients a and b of the given equation are: for a equals to 1.46, 1.224, 1.695, and for b we have 0.4094, 0.3825 and 0.4363. Now we will also have to give the commands for plotting the function. We have f is equals to fit temperature temp thermex power 1, and we will then give the command to the MATLAB to plot the function plot f temp thermex, and we will get the graph that can be seen here. Here we have two lines, one is dark red color and the other one is blue color. The red color line shows the fitted curve and the dotted points show the data of the given question. You can see this graph and understand easily what is how we have fit a single power term in the power series model. Then another command for the given question, summation n equals to 0 to infinity y plus x power n divided by n factorial. If we have the solution of the given differential equation in such a form, then how we will plot this? Well, we will first command should always be the clear command, CLC and CLER. Then secondly we will have to define the symbols SY, MS, X for y equals to 0. Okay, now for and end command, for n equals to 0 colon 2, y is equals to y plus x power n divided by factorial of n. So you can see how we have written the given equation in the MATLAB by using the for command, and then obviously what we did in the previous commands, that we have to end the command. Similarly we will give the command end to the MATLAB. After giving the end command and pressing enter, we will get values such as y equals to 1, y equals to x plus 1, y equals to x squared by 2 plus x plus 1. And if we write them together, they are 1 plus x plus 1 plus x power 2 by 2 plus x plus 1. And that is the answer of the given solution of the power series method. That is it. In this video, in this presentation, we tried our best to help you learn about power series substitution method for the differential equations and how we can easily solve any type of differential equation using power series method. It is such an easy method. You will only have to understand the basic rules for solving the equations. Once you have understood the rules, then you can solve any type of differential equation using this method. Secondly, we have also tried to give you a vague idea of how to solve this power series solution on the MATLAB. We know that MATLAB is the most commonly used software nowadays. It is used in almost every field. So you should know how to solve these power series equations on the MATLAB. To conclude, if we have to perform the power series function on the MATLAB, we will have to use for and AND command along with hold on command. And if we want the plot of the given function, we will have to use the plot command. And we can also use different colors to plot the given graph. That's it. Hope you have understood clearly about the series substitution method for solving